In this video, we're just going to look at two different ways to calculate the area of a triangle that are different from the standard formula, which would have been 1/2 multiplied by the base multiplied by the perpendicular height. So you can see the two formulas here. One of them is 1/2 AB sine C, and the other one is the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C all over 2. But for both of those formulas, we just need to make sure that we know how the sides and angles of a triangle are named in relation to each other. So we can see on the right here, we've got the triangle ABC, and we've got the points marked A, B, and C. These are the corners of the triangle. They're marked with uppercase letters. And the angles at those points are also given uppercase letters, and they're given the same letter as the point they're at. So angle A is at point A, angle B is at point B, and so on. Now the sides of the triangle are named in relation to the angle that they are opposite to. So for example, side A down the bottom is opposite to angle A at the top, and then side B on the right is opposite to angle B on the left, and side C here on the left is opposite to angle C on the right. And the other thing that we've got to make note of is that the sides are all named with lowercase letters and the angles are all named with uppercase letters. We look at our first formula here. 1/2 AB sine C is 1/2 times the length of two lines multiplied by the sine of the angle in between them. And this won't just work with AB and sine C, it will also work with other ones. So for example, you could go with 1/2 AC times the sine of B, or you go with 1/2 BC times the sine of A. We aren't restricted specifically to one corner of the triangle for this. It will also work with these. It's just that you will most often see the formula presented like that. And for this other formula here, we're told that the area is S times S minus A times S minus B times S minus C, all under a square root. And S is the sum of all the sides, A, B, and C, over 2. I'll take a look at a couple of examples of these so we can see how these work out. So, for this first one here, it's relatively straightforward. We've been given two sides and the angle in between. So we can use the 1/2 AB sine C formula for this. So it'll be 1/2 times 16 times 20 times the sine of 30. And you can stick that straight into a calculator if you want, but if you do it step by step, 1/2 by 16 by 20 is 160, and the sine of 30 is 1/2. So our area for this is just going to be 80 units squared, like that. So that's straightforward enough for that one. Now for our second triangle here, we've only been given one side and we've been given two angles. So it looks like we won't be able to get the area for this, but we might as well fill in this third angle and see if any information comes from it. So all three angles inside a triangle should add up to 180. So this third angle up here is going to be what we get if we take the measure of the other two away from 180. So 180 minus 74 minus 32. Well, when we do that out, we actually get 74. So this angle up here is also 74 degrees. So in a triangle, if we've got two equal angles, then the sides opposite those angles are also going to be equal. So this 9 is opposite to this 74 down here, which means this side over here, which is opposite our 74 that we just filled in, is also going to be equal to 9. And now what we have is we have two sides and the angle in between, so we can get the area for this. The area for this triangle is going to be 1/2 times 9 times 9 times the sine of 32. If we stick that straight into a calculator, we'll get 21.4617302 units squared, like that. Nice and straightforward. And then we'll take a look at the question just with the other formula. So in this one, in this triangle, we've been given no angles. We've only been given the lengths of the sides, which means we'll have to use the formula you can see here in the white box. The first thing we have to do for this is we've calculated S. That's what S is just there. S is equal to that. So our S is going to be equal to 12 plus 8 plus 6 all over 2, which is just equal to 13. So now we can calculate our area, filling in all the information we have. So it's going to be 13 times 13 minus 12 times 13 minus 8 times 13 minus 6, and that all goes under a square root sign, like that. So it's going to be 13 times 1 times 5 times 7 all under a square root, which is going to give us a square root of 455, which is equal to 21.33072901 units squared. And that is that.